Hello, everyone. Welcome to Chapter 1 of Statistics. We're going to cover all of Chapter 1 in this one video. And we're going to start out with some definitions. We're going to start out with the word data. Data are collections of observations such as measurements and survey responses. And the singular, so data is plural, singular is datum. Next up, we have the word statistics. It's the science of planning studies and experiments, obtaining data, and then organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusions based on the data. And our next definition is the population. Is the entire group being studied. For example, all of the men at Long Beach City College that are of a certain age group or something like that. This is versus a sample. And we will be, for the entire semester, be comparing a sample and hoping that that sample represents the population. Sample is always going to be a subset of the population. So if I only gathered men of that certain age group on certain parts of campus, I would use the results of the sample data to hopefully eventually infer something about the entire population being studied. Number 5 is the census. Is the collection of data from every member of the population. In real life, this is not very realistic. It's just getting all data from the entire population just is not a realistic thing. And so we would need a sample to do our best with that. For this class, we're going to study two types of statistics. The first type is called descriptive. And this consists of organizing and summarizing data through numerical summaries, tables, and graphs. For the first more than half of the course this semester, we will be doing only descriptive statistics. The good stuff starts in chapter 7 and 8 when we get to the inferential. It uses methods that take a result from a sample and extend it to the population, and then measure the reliability of the result. So you can see the word infer is here, big I at the beginning. And the idea is we want to use a sample to infer something about the population itself. That really is the goal for most studies that we're looking at. All right, number 8, a parameter, and we're going to practice this in a few minutes. A parameter is a numerical measurement describing some characteristics of a population. Now, we tend to look for, when we're talking about a parameter, typically we are looking for mu. That's a Greek letter mu, mu. You can see it kind of looks like an M, looks kind of like a U as well. That represents the population mean. The true proportion of a population, meaning what percent of people think this way or something like that, of the true proportion. And then we have the standard deviation, or variance if we do. That's a Greek letter, lowercase s, called a sigma. And these letters, Greek letters, that and more Greek letters will come up during the semester. So we'll re-emphasize them in a bit. A parameter is compared to a statistic, which is a numerical measurement describing a characteristic about a sample. Now, above in the blue here, you can see the mu represents the mean or the average. The p is the true proportion, and the sigma is the true standard deviation. If we're using a sample, we use slightly different letters for this. We use x bar for the mean. We use what we call p hat for the sample proportion. And we use just a capital S for the sample standard deviation. And one thing that we are always going to be cognizant of is sampling error. And I'm not going to read through the whole thing, but basically sampling error is when we're using a sample to represent the population, we know it's going to be off a little. And so what we try to do is just contain that and make sure that we're within certain parameters so that we're not diluting ourselves with the results. And we have some cute little drawings here. And you can see my Greek letter mu down here to represent the population mean. So we have a population, and the parameter for this is going to be the population mean, the mu. We use a random selection process, and we'll talk more about that in a few minutes, to obtain a sample. And we can find the mean of that sample. And you can see we have our X bar here that represents a statistic or a sample mean. And based on that sample, we're going to be able to infer something about the entire population. So this is the basic process that we're going to be using for the semester as we move forward. And here we have a problem from ALEKS. It's a little long, but this is going to really help us to figure out the difference between the population and the sample. So Melissa, a nurse manager at a local hospital, wanted to know more about the hospital's full-time nurses. She polled 12 nurses at random who work full-time in the hospital. Now, this so far is definitely talking about a sample because we know that there's more than 12 nurses at this hospital. The findings in the poll were that these nurses take on average 5.5 sick days per year, and that 50% of them would prefer a 4-day work schedule, and that 8 of them are married. Melissa didn't know that the top hospital administrators had already surveyed all of the nurses. So there we are. Now we're talking about population. So this here is the sample, and this here is the population. In that survey, it was found that the nurses take, on average, 5.76 days per year. 61% of them would prefer a 4-day work schedule, and that 77 of them are married. So in ALEKS, for part A, where it says choose one for both, those are both drop-down menus. So you just click on those. The population is going to be for all nurses. And the sample is going to be just for the 12 that Melissa polled. And so we're going to take these numbers from this story problem, and we are going to figure out if they are a parameter, meaning they have to do with the population, or if it's a statistic, which has to do with the sample. So once again, I want to point out that this is the population, and this is the sample. So the average of 5.5 sick days per year, so 5.5 sick days per year, that is having to do with the sample. So that is definitely a statistic. The 77 nurses, let's find that. 77 nurses that are married, that is under the population. That's a parameter. And the 61% of full-timers that preferred a 4-day work schedule is right here. Again, that's having to do with all nurses, so that is the entire population. So it's a parameter. All right, and we have one more definition for the first part here. This is called a voluntary response sample. And this is one in which the respondents themselves decide whether to be included. So this would be if there's a website that someone chooses to go to and wants to participate in a survey of some sort, this would be a voluntary response sample. These are often not too reliable because usually the only people that go to and do these surveys have a real vested interest in them. And so they're going to have a pretty sharp opinion one way or the other. And depending on what website it's on, it could certainly, if people of a certain mindset are all going to that same website, then they're probably all going to vote the same way as far as what the responses would be. So it can be a little tricky. We'll talk about better ways of gathering data here in a bit. All right, part two. So we have two definitions here. We have quantitative, quantitative, consists of numbers representing counts or measurements. So these usually are associated with numbers that have meaning. This is versus categorical. Categorical data consists of names or labels that are not always representing counts or measurements. And we have some examples here. So we'll go ahead and practice this. Here we go, and keep the definitions there. All right, a closing price in dollars of a stock. That is definitely going to fall into the quantitative, meaning we have numbers that have meaning here. Part B, anxiety rating, highly anxious, moderately anxious, or relaxed. That is definitely categorical. There aren't any numbers of meaning that have any significance to this here. The amount in fluid ounces of coffee in a cup dispensed by a vending machine. That is also, that's going to be quantitative because that's a quantity because it's in fluid ounces. So it's a measurable quantity. And part D is the name of a cell phone service provider. That's definitely categorical. There aren't really any meaningful numbers that would be associated with that. All right, let's continue on. Quite a bit of definitions in chapter 1 here, and in chapter 2, actually. So we're going to start here with the word discrete. Results when the number of possible values is either a finite number or a countable number. And this is versus continuous. So continuous number values result from infinitely many possible values that correspond to some continuous scale that covers a range of values without any gaps or jumps. All right, so let's go through some examples here. Part A, the time it takes to drive from home to work or school. That is definitely going to be continuous. The number of personal injury traffic accidents last week on Interstate 65 in Indiana. That is definitely discrete because we can count those. We can count exactly how many of those happened. Part C, the temperature of a burrito served to a customer in a local Mexican restaurant. That is definitely continuous. Part D, the body weight of a preschool child. That is also continuous. So you might be thinking to yourself, no, wait a minute, the body weight of a preschool child, that we could say that they're 40 pounds or 20 pounds or 22 pounds. The problem is no one weighs exactly that, right? So if someone weighs 40 pounds, they're probably 40.073 or something like that. And definitely that fills in all the empty gaps there. So it's definitely not countable. All right, we are going to break this down even further. And we're going to start with ratio. Ratio is a level of measurement where there is a natural zero starting point, and the ratios are meaningful. Some examples are heights, lengths, distances, and volumes. The main thing here is a natural zero, and we'll talk about some counterexamples to that here in a moment. Ratio versus interval. Interval is a level of measurement, have differences that are meaningful, but there is no natural zero starting point, and the ratios become meaningless. So an example of ratio would be my height. So if I'm 5'8", we could find someone that is exactly half my height, right? So that's a meaningful ratio. And there's a natural starting point, and that starting point is when I'm first is 0, right? When I'm not there at all. Versus an interval. If we think about the way we list our years, so let's say back in 1995, if I cut that in half, that really doesn't that number that's in half of that really has no meaning. Even if we go all the way back to the year 1 CE, and then we go to 1 BCE, and then we go back to the dinosaurs 65 million years ago, right? And so the years that we use, there really is no meaning to them. There's differences that are meaningful, but the ratios are not there, and there again is no natural 0 point. All right, next up we have ordinal. Is a level of measurement where the data can be arranged in order, but differences either cannot be found or are meaningless. They list ranks of colleges. So ordinal would be something like small, medium, and large. So there's a definite order to them, but we can't really measure those. And this is versus nominal. So this is level of measurement that are only categories. There's no natural order to them. So if we were to list all of the countries on the planet, there's an order if we put it in alphabetical order, but if we go to another country, they may spell it differently, and so suddenly it's out of order. So those would be nominal. Eye color would be another one. Religions would be another one. There's no natural order to that. All right. By the way, I do want to point out that these two here are quantitative. And these two here are categorical. And so this is just a further way of breaking down this data. And let's do some practice. All right, so we're going to decide if it's quantitative or categorical. And by the way, you can see the word quantity in the word quantitative. So that's, again, has to do with numbers. So let's do part A. Color vision status, colorblind or not colorblind. That is going to fall into a categorical, and that is specifically nominal. There's no order to that. Next up, anxiety rating, meaning highly anxious, moderately anxious, or relaxed. That is going to be quantitative, categorical, pardon me, categorical. And that definitely has an order. So that's ordinal. Temperature in degrees Fahrenheit. That is going to be quantitative for sure. And that actually is interval when we're talking about Fahrenheit, because 0 degrees Fahrenheit really has no meaning, because then it goes into the negatives as well. So that's an interval example. And we have a few more examples. Part A, the amount in fluid ounces of coffee in a cup dispensed by a vending machine. That is quantitative. And that is definitely going to be ratio. We can have a 0 amount of coffee. And one could say that cup holds twice the amount of coffee that mine does. Length in feet of a roll of plastic wrap advertised to be 30 feet long. Now, this is quantitative. And this one is ratio as well. Name of manufacturer of an automobile. Okay, that's definitely categorical. And that is going to be nominal. There is no natural order to that. All right, what are the third part? How do we collect data And when I say collect data, I mean we're doing it in a non-biased way. And you'll hear me use the word bias quite a bit because we always have to look out for any kind of bias, and there's always bias. All right, we have two different types of ways of what to do with the data once we get it. We can do an observational study. In an observational study, we observe and measure specific characteristics, but we do not attempt to modify the subjects while being studied. This is versus an experiment. We apply some treatment and then proceed to observe its effects on the subjects. So an observational study would be if you wanted to go to the Serengeti Plain in Africa and observe lion behavior. You would want the lions to not even know that you were even there. You just want to observe their natural habitat, what they're naturally doing, their hunting habits and mating habits, and whatever that you would want to observe with a study like that. In my classroom, what I would say is I want to put cameras up and see who messes with their cell phones more, men or women, in my classes. And I certainly wouldn't want my students to know that the cameras were there, because then they would never touch their cell phone, and that would skew the thing. And I've never actually done that, and I never would, of course. That's kind of creepy. So the experiment would be, so a doctor wants to see if a medicine works. So half the people get the medicine, the other half get a placebo, which is like a sugar pill. And they don't know. In fact, the people administering it don't even know which ones they're administering. That's called the double blind test. But that really is the best way to see what works and what doesn't. And we're going to go through and decide if which of these are an observational study or an experiment. All right. A marketing firm does a survey to find out how many people use a product. Of the 100 people contacted, 15 said that they use the product. This is an observational study, because they're not trying to modify anything. They're not trying to find out anything about the product itself. They just want to know who's using it. Second one, a clinic gives a drug to a group of 10 patients and a placebo to another group of 10 patients to find out if the drug has the effect on the patient's illness. This is clearly an experiment. Next one, a sample of fish is taken from a lake to measure the effect of pollution from a nearby factory on the fish. This one's just an observational study. They're not trying to cure the fish or remove the pollutant or anything like that. They just want to know what the effect of the pollution actually is. Last one here. A quality control specialist compares the output from a machine with a new lubricant to the output of a machine with an old lubricant. This is classic experiment. Yeah. Let's practice. Washington High wants to estimate the number of students who drive to school. Answer the following. Which of the following students surveys probably would best represent the entire student population? 50 students are randomly selected from the school. 11 drive to school. 50 students are randomly selected from the Glee Club. 15 drive to school. 50 students are randomly selected from the 10th grade. 10 drive to school. Well, if we look at the original statement, it just wants the school population. So I would say for sure, we're looking here. Doesn't say anything about the Glee Club, doesn't say anything about the 10th graders. Part B, there are 1,950 students at Washington High. Using your answer from part A, estimate the number of students who drive to school. So we are going to set up. So this is going to be 11 is to 50. So that's the percent. We divide that out. That's going to give us 22%. And now we're going to apply that percent to the total. And the total was 1,950 times 0.22. So 429 students. And you, of course, would put that there, right? When you're doing your homework. Let's do another one. A political campaign wants to estimate the number of adult residents who voted in the last city election. Answer the following. Part A. Which of the following surveys probably would best represent the entire adult population of the city? First one, 25 adult residents were randomly selected from the city. 10 voted in the last election. Next one, 25 senior residents are randomly selected. 11 voted in the last election. Last one, 25 business owners are randomly selected. 14 voted in the last election. Well, the original statement only talks about just residents from the city. So once again, I would say it's this first one. And it says that there are 23,700 adults who live in the city. I'm going to write that number down. 23,700 adults. And from part A, I can see that 10 out of the 25 voted in the last election. So let's take 10 divided by 25. This gives us 0.4 or 40%. And now we're going to apply that 40% to the 23,700. So this is 9,480 residents. There you have it. So a little bit of math in the get right off the first chapter here, not much. All right, now we're going to talk about sampling techniques. These are good sampling techniques. And then we'll talk about bad ones as well. But first, the good ones. In a random sampling, members from the population are selected in such a way that each individual member in the population has an equal chance of being selected. The classic one is everybody puts their name on a piece of paper. They put it into a bag, they shake up the bag, and they close their eyes and they reach in and grab one. Everybody equally has a chance of being chosen. That's random sampling. Next up, we have systematic. Systematic sampling, we select some starting point and then select every kth element in the population. This would be, for example, there's a crowd of people and I start with one person and I count 1, 2, 3, 4, they're in. 1, 2, 3, 4, they're in. 1, 2, 3, 4, they're in. Yeah, so that's what they mean by kth. So maybe we need every 12th person or whatever it is that we're doing. Next up, we have stratified. With stratified sampling, we subdivide the population into at least 2 different subgroups so that the subjects within the same subgroup share the same characteristics. So when we draw from the we draw a sample from each of them. This is versus cluster. We subdivide the population into sections or clusters, and then randomly select some of those clusters, and then we choose all of the members in the selected clusters. Stratified, we have meaningful groups, and we get a few from each group. Cluster would be they're put into groups, and then groups are selected, and we test everybody in the groups that are selected. I know they sound similar. Picture a committee wanting to be formed for basic skills at a community college. So what they would want to do is make sure that they had at least a math teacher there, a reading teacher there, an English teacher there, an ESL teacher there, right? So just we're broken into meaningful groups, meaning the math, the reading, and so on. But we don't need everybody from the group. So it's just a few from each group. That would be stratified. Cluster would be if we wanted to go to all of the, we're looking at Southern California community colleges, and we select 4 of the colleges, and then we test everybody in that college. Maybe the administration, we want to check for something. That would be cluster. Now, here are the bad ways to gather data. Unfortunately, these are often used. The first one is purposive or judgmental. And basically, this is, I'm going into this experiment and this is the result that I want when we're done. And so you go in with this major bias, maybe even knowing that you have this bias, and you make the answers say what you want it to say. For example, let's say that that I wanted to ask the question, does God exist? And so if I only went to churches and mosques and synagogues, I'm going to get a specific answer. Now, I'm an atheist, so I would need to look out for the other side of that, which would be if I only go to atheist conventions and only talk to atheists and ask them that question. Both would be very purposive and or judgmental. So both would be inappropriate. So what you would want to do is whatever bias you have, acknowledge that you have that bias and do your best to avoid that bias. Convenience sample. This is if you happen to be at the right place at the right time and you're like, you know what, let me just ask these people. That's a very lazy way of gathering data. You would want more of a plan than whoever happens to be sitting in the same room as you or something like that. For example, if I was in a classroom and I wanted to find out something about the community college that I'm working at, well, I could just use my classroom and use that as data. But again, that's very convenient for me, but it's not very helpful. The quota is the third way that's not so good. You can imagine if you have a minimum or a maximum to do that, after a while, if you're not hitting your target, you might start saying your product is a little bit better than it is, or whatever it is that you're trying to sell, and you could start tweaking it just so you get those numbers that you're looking for. So it's not so good. So those are 3 ways that you want to make sure if you're doing an experiment you avoid. And let's practice. Right. A botanist at a nursery wants to inspect the health of the plants in the nursery. Which of the following best describes a systematic sample of plants? The first one. The botanist assigns each plant a different number using a random number table. He draws 64 of those numbers at random. Then he selects the plants assigned to the drawn numbers. Every set of 64 plants is equally likely to be drawn. That sounds like a random sample to me, so that's not systematic. The second one. The botanist forms 4 groups of plants based on the ages of the plants in months. Then he selects 16 plants at random from each group. That's stratified. That's definitely not systematic. The third one. The botanist takes a list of the plants and selects every 4th plant until 64 plants are selected. That is our winner. That is definitely systematic. Part B. Counselors at a college want to poll students about how much time students spend studying. Which of the following best describes a convenience sample of students? First one. The students living in a particular dorm building on campus are easily accessible, so the counselors select 56 students living in that particular dorm building. That sounds like convenience sampling to me. The counselors use a computer program to draw 56 students at random and select these students. Every set of 56 students is equally likely to be drawn by that. That's a random. And the counselors take the list of students and select every 7th student until 56 students are selected. That is systematic. So we're definitely looking at this first one as being the convenience sampling. And the reason I'm reading all of them is I want us to identify each of the different types, even though we already found the one that we were looking for. Part C. The organizers of a conference want to survey attendees about the registration fee. Which of the following best describes a stratified sample of attendees? First one. The organizers select the first 50 attendees who register for the conference because these attendees are easily accessible. That's convenience. The organizers form two groups of attendees based on the attendees' employment statuses. Then the organizers select 25 attendees at random from each group. That's definitely stratified. I'm going to read the last one anyway. The organizers form groups of 10 attendees based on the day the attendees registered. Then the organizers randomly choose 5 groups and select all of the attendees in these groups. That one is cluster. So we are definitely looking at this middle one here. All right, we have a few more. A host on a cruise ship wants to collect data on the time passengers spend at various activities on board. Which of the following best describes a random sample of passengers? The host assigns each passenger a different number. Using a random number table, he draws 50 of those numbers at random. Then he selects the passengers assigned to the drawn numbers. Every set of 50 passengers is equally likely to be drawn using the random number table. So that's definitely random. I'm going to read the other two anyway. The host selects the first 50 passengers who board because these passengers are easily accessible. That's definitely convenience. The third one, the host forms two groups of passengers based on the levels of the ship that the passengers' cabins are on. Then he selects 25 passengers at random from each group. That's stratified. So definitely the random is going to be this first one here. Part B. A chemist at a pharmaceutical company wants to test the quality of a new batch of microscopes. Which of the following best describes a cluster sample of microscopes? First part. The chemist forms groups of 12 microscopes based on the laboratories that the microscopes are in. Then he randomly chooses 5 groups and selects all the microscopes in those groups. This is definitely the cluster. And the keyword here is all. Next one, I'm going to read the other two. The chemist takes a list of the microscopes and selects every 6th microscope until 60 microscopes are selected. So that is definitely systematic. Third one, the chemist assigns each microscope a different number. Using a random number table, he draws 60 of those numbers at random. Then he selects the microscopes assigned to the drawn numbers. Every set of 60 microscopes is equally likely to be drawn using the random number table. That's definitely random there. Part C. A city manager wants to poll residents about a park renovation. Which of the following best describes a stratified sample of residents? The city manager forms groups of 13 residents based on the streets the residents live on. She then selects all of the residents in 6 of the randomly chosen. So that is, again, the keyword there is all. This is definitely cluster. Blank there for a second. The city manager forms 6 groups of residents based on the residents' incomes. Then she selects 13 residents at random from each group. That one is definitely stratified. So that's going to be our answer there. The last one, the city manager takes a list of these residents and selects every 3rd resident until 78 residents are selected. That is definitely systematic. And here's sort of a breakdown of the probability ones, the good ones. So the simple, random, systematic, cluster, and stratified. And the bad ones are the judgment, the convenience, and the quota. All right, I want to thank you. Hope this helped.